Hi friends, welcome back. In this video, we are going to see how to protect Couchbase cluster with root, intermediate and node certificates. The certs generated in the previous video is just for demonstration purpose. We are actually going to upload these certificates from all the nodes. So let me pick a new node, selecting this. I'm selecting this node as there are no certificates generated for this node. You can see the valid from dates are different. Right now it is showing only 6 nodes as we have already generated and uploaded the certificates for one of the nodes in the cluster. Let me connect to this node. Let me create the directories. Change to root directory and create a config file. So I have added an extra parameter to this config file. As you see here, I have added IPs under alt names. This section I have added additionally. The reason for adding these IPs is when we are using fully secure XDCR feature with client certificates, Couchbase expect the IPs to be binded in the root certificate. You can add DNS also instead of multiple IPs like DNS 1, 2, so on and so forth. So for now, I'm copying this config file. Create the root certificate. So OpenSSL is not available on this server. Let me install it. It is installed. Enter the passphrase. You have to remember this password. We need to enter this in one of the next commands. Create an extensions file that will limit the capabilities of the intermediate certificate. Create a private key and corresponding certificate signing request for the intermediate certificate. Enter the passphrase. Create the intermediate certificate specifying the root certificate and its private key to establish root certificate's authority. Enter the passphrase for _ca.key. This is nothing but the password we set when we are generating the private key. Save the intermediate certificate. Within the servers directory, create an extension file containing the information that will be generic across all the individual nodes for the cluster. It is created. Generate the private key to be used for the individual cluster node. Generate the certificate signing request for the node certificate. The CN we can change it as per our convenience. Add node specific information for each node. This current example is assuming this is a single node cluster. This step would be repeated for each node in the cluster if the cluster contained multiple nodes. So we have to generate step 11 and 12 for each and every node of the cluster. So we have to create a temporary extension file for each node and use that temporary extension file to generate individual node certificate. Instead of generating it multiple times, I'm trying a workaround. I have included all my cluster nodes like this. I want to generate one set of certificates on this particular node and I will copy these certificates to rest of my cluster nodes. Since I have already included all the IPs here, I should not get a problem when configuring fully secure XDCR using client certificates. Create the node certificate for an individual node. Enter the passphrase of the private key. Whatever password I set earlier, I have given the same password here. Check the node certificate is valid or not. I got OK message. Prepare to deploy the certificate and private key for the node. This is my chain.pem. and this is the private key. Let me create the inbox directory and copy the node certificate and private key into it. Upload the root certificate, thereby activating it for the entire cluster. So with this command, it will update the certificate for the entire cluster. Then reload the node certificate from the current node. So reloading the certificate should happen from every node, which means whatever certificates chain.pem and pkey.key we have generated, we need to copy these two certificates into all the cluster nodes. And then we need to run this reload certificate command on all the nodes. In this example, they assumed this is one node cluster. If the cluster contains more than one node, the reload certificate command must be executed on each node, specifying the IP address of the node on which execution is happening. Let me update the IP address. Let me upload the root certificate. Before that, I need to switch to root directory. This is the root certificate inside root directory. We have received few warnings. Let's ignore this and proceed with the reload command. Before reloading, let's check the certificate. Still the dates are not reflected. Let's reload it. So it's reloaded. Let me reconnect. We should not see warning for this internal IP. So as you see, it is not displaying warning for this particular internal IP here. Let's verify the dates. The dates has been changed and we can see 3 certificates: root certificate, intermediate certificate and the node certificate. And we can also check subject alternative names. I can see the list of IPs provided. Now let me copy the same set of certificates to the other nodes. You can also generate node certificate for other individual nodes with step 11 and 12. Once this node specific certificate is generated for other nodes, you have to generate chain.pem for other nodes also by using this command. As you see here, it is concatenation of the node certificate and the intermediate certificate, which will establish the chain of authority. So let me quickly copy the certificates to other nodes. As root certificate is already uploaded to the cluster, we can only copy chain.pem and pkey.key. As I have habituated working with 3 certificates, although it is not required, I want to copy the root certificate also along with these 2 certificates. As you see here, I have connected to rest of the cluster nodes. Inbox directory is empty. Here also it is empty. Few of the nodes doesn't even have the directory, so I'm going to create it now. Now let me switch to inbox directory on all the nodes. Let me copy the root certificate to all the nodes. Reiterating again, although it is not required, I'm simply copying it. Now let me copy chain.pem and pkey.key as well. Now copying pkey.key. Let me cat chain.pem and pkey.key. They're looking good. Now let me run the reload certificate command on all the nodes. I can execute this command from one node itself because the connectivity is there among all these nodes. First let me execute one command. Before that, let's see how many warnings we are able to see right now. 6 warnings. Now let me refresh this. It should show only 5. We can see only 5. Let me execute all these commands. We can connect to individual node and execute, or we can also execute from one node itself. It is completed. Let me refresh again. Now there are no warnings. We are good. Certificate also looking good. Let me connect to different IP and see whether we are getting any warnings or not. We should not get any warning from any of the nodes. Let me reconnect. Valid from dates are looking good. Subject alternative name showing all the IPs. Root certificate also looking good without any warnings. Please note that 99% the process will be different for every organization. For example, in my organization we will be using our organization specific certificates, but the end certificates just like chain.pem, root.pem and private key, these 3 certificates are common. So this is about how to create cluster certificates with root, intermediate and node certificate. Thanks for your time. See you in the next lecture.